Hello, in this class we are going to talk about how to draw a box plot. Okay, so the data below represent 15 exam score for fictional statistic class. The first thing is you want to connect the 5-number summary to calculate the interquartile range. So first we have minimum, Q1, medium, Q3, maximum. Let's try to remember how do we do that. So minimum, easy. Maximum, also easy. After you order the data. Now, medium is going to be the center of the data. Since you have 15 data here for this data set, so the medium is going to be the middle of the data. So it's going to be the 1/8 of the data, which is 82. This is going to be our medium. Now, Q1, since medium already used, so that means Q1, you're going to find Q1 is from the rest of the data, not including the medium. So we have this first half of data. Through this first half data, we want to find Q1. So we have, oh, sorry, I found the medium wrong. The medium should be the 1/8 of the data. In this case, should be this guy. I mean, they're all 82, but should be the 1/8 of the data instead of the 7th of the data. So here's our medium. So in this case, the first half of data is here, right? So we totally have 1, 2, 3, 4, 5, 6, 7. So among these 7th data, we want to find the middle of the 7th data. That means it's going to be this guy, right? The 4th of the data. So here is our Q1, 70. Now Q3 is the rest, the second half of the second 50% of data. So we have another 7 data. The sample size is 7, and then the medium is going to be 94. So here's our Q3. Our interquartile range is equal to Q3 minus Q1, which is 94, subtract 70, which is 24. Now, determine the scale and draw a vertical line at medium, Q1, and the Q3. So the first step is you want to have a number 9 to including all of the data. So now let's draw a number 9. So in this number 9, you want to from 30 to 100. So not 900, 90. So draw a vertical line at medium, Q1 and Q3. Our medium is 82. So 82 is approximately here. Medium, I'll label it. Q1 is 70. Q3 is equal to 94. 94 is approximately here. Okay, connect these to form a box. So here is the box. And then label your horizontal axis, including the scale. So here is the horizontal axis. I already have that in here. So here's 18.2, 19.4, and 70. Okay, so how do we determine the outliers? So to determine the outliers, we use 1.5 times of interquartile range on each side of the box to determine the fence. So we have upper fence. Upper fence is going to be Q3 at 1.5 times of the interquartile. So in this case, look at our Q3. Q3 is 19.4, and then 1.5 times of the interquartile, which is 24. We add that. So basically, our interquartile is from Q1 to Q3, right? That's the width of the box. And then 1.5 times width of the box gives you the upper fence. So here, this is equals to 130. Lower fence is the similar idea. You want to use the Q1 to subtract 1.5 times the width of the box. So Q1 is 17. You subtract 1.5 times interquartile, which is 24. That gives you 13.4. So now let's label it. So our upper fence, oops, this is 110. We need to add another 2. 120, 130. So upper fence, I'm going to use different colors of pen. Upper fence is here. We add in 1.5 width of the box from the Q3, which is equal to 113. And then lower fence is we use 70 to subtract 1.5 times the width of the box. Remember, the interquartile range basically is the width or the length. Here, this part is the interquartile range. This is going to be 1.5 times of the length of the box is your lower fence, which is at 34, approximately here. Okay, so now be careful in here. Never draw the fence. They are not technically part of the graph, just bounds to determine the outliers. That's why I use a red pen instead of a purple. You just let yourself know that, hey, we have a fence here. On your exams or quiz, you can, if you have a different color, if you don't have a different color of pen, you can use a dash line to remind yourself that, hey, outside of this fence is going to be the outliers. Now, let's label which data is outside of the fence. The data outside of the fence are considered outlier. If they're inside, that's fine. All right, so now let's take a look. We only have one data, which is 31, is outside of the lower fence. Other than that, all of the data are inside the fence. So now I'm going to use back in our purple pen to draw that, to make a star to mark that, hey, this one is our outlier. Okay, remember we can draw a fence. Now it's time to draw our whiskers. So what is whisker? Whisker is draw the line to the nearest data value inside of each fence to make the short vertical bar. Label each value outside the fence outlier with a dot. So I use a star to label the outliers. So after the outliers, the first data inside of the lower fence is going to be 62, right? So that means our whisker bar, the first whisker bar is going to be 62. So we're connecting them in here. And then on the other side, the upper fence. the first data near the inside upper fence, but the closest one inside upper fence is going to be 100, right? So that means the other whisker bar is going to be 100. So this is a box plot. So now let's continue. Continuing with our test score dataset, draw a graph describing the distribution. Be sure to talk about the shape, center spread, and any unusual feature. So we already have a graph, which is our box plot. From our box plots, again, the red pen one is not supposed to show up on the graph because they're the fence. I use a red pen to show you the step how do we find it. But in fact, only the purple color pen should be on the graph. So here's the Boxplot fence, or you can use another way to draw our test score. We can use histogram. On a histogram, we might again separate the data from 13, 40, into different groups. And then for 100, we have 1 student. From 80 to 100, we have 3 students. And then for 18 to 19, we have 1, 2, 3, 4, 5, 6 students. And then from 17, the group 17 to 80, we have 2 students. And then 60, we have 2 students as well. And then for 14, we have 1 student. So you can also have a histogram graph to show that this graph is skilled left. Also, a box plot would be maybe better in this case because they show you which one is the outlier, which one is the whisker. It gives you the box, which is in the length of the box or the width of the box is going to be the interquartile range. So in here, let's talk about the shape, the center, and the spread. So in here, the shape is scale left. The center, where's the center? The center, which is the medium score is 82. And then for the spread. So since this is the skill data, when we discuss skill data, how we discuss the spread, we use interquartile range. So that means most of the score, which is our interquartile range, is between 70 to 94. And then there is 1 outliers. Which is 13.1. Okay, so this is very important to starting with a skill data, because we know that if the data is not skill, we should use, if the data is not skill, we should use mean and the standard deviation. So here is a summary. There are 2 different sets of measure for the center and spread. For skill data, we use mean and the interquartile range because these 2 is going to resist to the outliers. The outlier causes the scale data, the scale distribution. For symmetrical distribution, the center is very close to the mean, or they are equal. So we use standard deviation to describe how the data spread. Okay, that's it for today.